Propagation of sound. Sound is produced by vibrating objects. The matter or substance through which the sound is transmitted is called a medium. It can be solid, liquid, or gas. Sound is a mechanical wave. When an object vibrates, the particles around the medium vibrate. The particle in contact with the vibrating object is first displaced from its equilibrium position. It then exerts a force on the adjacent particle, and the adjacent particle is displaced from its position of rest. After displacing the adjacent particle, the first particle comes back to its original position. This process repeats in the medium till the sound reaches the ear. The disturbance produced by the vibrating body travels through the medium, but the particles do not move forward themselves. A wave is a disturbance which moves through a medium by the vibration of the particles of the medium. So sound is considered as a wave. Since sound waves are produced due to the vibration of particles of the medium, sound waves are called mechanical waves. Propagation of sound. Take a tin can, remove both the ends to make it a hollow cylinder. Take a balloon and stretch it over the can, then wrap a rubber band around the balloon. Take a small piece of mirror. Use a drop of glue to stick the piece of mirror to the balloon. Allow the light through a slit to fall on the mirror. After reflection, the light spot is seen on the wall as shown here. Talk or shout directly into the open end of the can and observe the dancing light spot on the wall. From this activity we can see sound makes a light spot dance. Sound needs a medium to travel. Sound is a mechanical wave and needs a medium for propagation. Sound travels through solids, liquids, and gases. Sound does not travel in vacuum. Let us explain with the help of activity. Suspend an electric bell in an airtight bell jar. Connect the bell jar to a vacuum pump. If the switch is pressed, we can hear the sound of the bell. If the air is pumped out through the vacuum pump, we cannot hear the sound of the bell. This shows that sound needs a medium to travel, and sound cannot travel in a vacuum. Compressions and rarefactions. Let us understand the compressions and rarefaction with the help of activity. Take a long spring and fix one with rigid surface and hold the other end with your hand. Now alternatively push and pull the string and observe. You observe that some regions of coil of spring come closer to each other and some regions move apart. These regions which come closer are called compressions and other are called rarefaction. Types of waves. Waves are of two types, transverse wave and longitudinal waves. When we fix one end of the string and vibrate from the other end in the direction perpendicular to the string, we have seen that the particles oscillate up and down perpendicular to the propagation of the direction of disturbance. Such a wave of propagation is called transverse wave. You can also see the transverse wave when we throw the stone on the still pond. It collides with a small rubble. These rubble propagate and expands on the surface of water as a transverse wave. In fact, these particles move up and down their mean position in the direction of perpendicular length to the propagation of wave. The wave particles move back and forth parallel to the direction of propagation of the disturbance. Such waves are called longitudinal waves. Let us explain with the help of activity. Stretch a slinky. Push and pull it alternately at one end. Observe the wave patterns. We can see that the wave of particles move back and forth parallel to the direction of the propagation of the disturbance. Such a wave of propagation is called longitudinal wave. Characteristics of a sound wave. Sound wave can be described by its wavelength, frequency, amplitude, time period, pitch, loudness, and speed of sound. Sound can be graphically represented as a wave. There is change in the density and pressure as sound moves in a medium. Compressions are the regions of high pressure and density where the particles are crowded. It is represented by the upper portion of the curve called crest. Rarefactions are the regions of low pressure and density where the particles are spread out and are represented by the lower portion of the curve called trough. The distance between the two consecutive compressions or crests or two consecutive troughs is called wavelength. It is represented by symbol Greek letter lambda. Its SI unit is meter. The number of oscillations per unit time is called the frequency of the sound wave. It is represented by the symbol nu. Its SI unit is hertz. The time taken for one complete oscillation in the density of a medium is called the time period of the sound wave. It is represented by letter T. The SI unit is second. The amplitude of the sound wave is the height of the crest or trough. Pitch is the characteristic of a musical sound which distinguishes a sharp or shrill sound from a dull or grave sound. If the frequency is high, the sound has high pitch, and if the frequency is low, the sound has low pitch. Since the sounds are traveling at about the same speed, the one with shorter wavelength will have a higher frequency or pitch. In other words, its sound is high. Loudness is the property of musical sound which determines the degree of sensation or loudness produced in the ear and thus enables us to distinguish between two sounds of the same pitch. The loudness of sound depends upon the amplitude of vibration. If the amplitude is bigger, the sound is loud, and if the amplitude is smaller, the sound is soft. Speed of sound. The speed of sound is different in different media. The speed of sound is more in solids, less in liquids, and least in gases. The speed of sound also depends on the temperature of the medium. If the temperature of the medium is more, the speed of sound is more. Speed is equal to wavelength into frequency is equal to lambda into nu. Reflection of sound. Like light, sound gets reflected at the surface of a solid or liquid and follows the laws of reflection. Let us explain with activity. Take two pipes of the same length and arrange them on a table near a wall or metal plate. Keep a clock near the open end of one pipe and try to hear the sound of the clock through the other pipe by adjusting the position of the pipe. Now measure the angles of incidence and reflection. It will be seen that the angle of incidence is equal to the angle of reflection. The incident wave, the reflected wave, and normal all lie in the same plane. Echo. If we shout or clap near a reflecting surface like a tall building or a mountain, we hear the same sound again. This sound which we hear is called echo. It is caused due to the reflection of sound. It is derived from the Greek word which means sound. To hear an echo clearly, the time interval between the original sound and the echo must be at least 0.1 second. Since the speed of sound in air is 344 meters per second, the distance traveled by sound in 0.1 second is equal to 344 meters per second into 0.1 second is equal to 34.4 meters. So to hear an echo clearly, the minimum distance of the reflecting surface should be half of this distance, that is 17.2 meters. Reverberation. Echoes may be heard more than once due to the repeated or multiple reflections of sound from several reflecting surfaces. This causes the persistence of sound called reverberation. In big halls or auditoriums, to reduce reverberation, the roofs and walls are covered by sound-absorbing materials like compressed fiber boards, rough plasters, or draperies. Look at the loudspeaker. How does it work? It is designed as a conical shape to send sound in a particular direction. The narrow end acts as a mouthpiece. It works on the phenomenon of multiple reflection of sound. The sound creates a narrow mount of piece and gets reflected many times by inner wall of conical funnel. As a result, the sound gets amplified and emerges a wide range. That is why we hear the speaker voice. Megaphones, horns, musical instruments like trumpets, etc. are designed to send sound by multiple reflection in a particular direction without spreading in all directions. Doctors listen to the sounds from the human body through a stethoscope. The sound of heartbeat reaches the doctor's ears by multiple reflections. Generally, the ceilings of cinema halls and auditoriums are curved so that the sound after multiple reflections reaches all parts of the hall. Sometimes a curved soundboard is placed behind the stage so that the sound after multiple reflections spreads evenly across the hall. Range of hearing. Human beings can hear the sound frequencies between 20 Hz and 20,000 Hz. Sounds whose frequency is less than 20 Hz is called infrasonic sound. Animals like dogs, elephants, rhinoceros, whales, etc. produce and hear infrasonic sound. Sounds whose frequency is more than 20,000 Hz is called ultrasonic sound. Animals like dolphins, bats, rats, porcupines, etc. produce and hear ultrasonic sound. Bats use reflection of ultrasonic sound waves to detect an obstacle or its prey. Ultrasonic sound is used to clean objects like electronic components. The components to be cleaned are kept in a cleaning solution and ultrasonic waves are sent into the solution. Due to the high frequency, the dirt particles get detached from the components. Ultrasonic sound is used to detect cracks in metal blocks. Let us see. Look at the setup. There is a computer, pulse receiver, transmitter and receiver. Move the transmitter device and receiver over the surface metals, and when there are cracks, ultrasonic waves are sent through the metal blocks. The waves are reflected back and the cracks can be detected. It is shown in a graph in the form of peak. Ultrasonic sound is used in ultrasound scanners for getting images of internal organs of the human body. Ultrasonic sound is used to break small stones formed in the kidneys into fine grains so that they are removed through the urine. Sonar. Sonar stands for Sound Navigation and Ranging. It is a device which uses ultrasonic waves to measure distance, direction, and speed of underwater objects. Sonar has a transmitter and a detector installed in ships. The transmitter produces ultrasonic sound waves which travel through the water, and after striking the object in the seabed, it is reflected back to the detector. The distance of the object can be calculated by knowing the speed of the sound in water and the time taken between the transmission and reception of ultrasound. If the time taken for transmission and reception of ultrasound is t and the distance travelled by the ultrasound is 2d, then 2d is equal to v into t, or d is equal to v into t divided by 2. Structure of the human ear. The outer ear called pinna collects the sound waves. The sound waves passes through the ear canal to a thin membrane called the eardrum. The eardrum vibrates. The vibrations are amplified by the three bones of the middle ear called hammer, anvil, and stirrup. The middle ear then transmits the sound waves to the inner ear. In the inner ear, the sound waves are converted into electrical signals by cochlea and sent to the brain through the auditory nerves. The brain then interprets the signals as sound. Sound. Sound is a form of energy which produces a sensation of hearing in our ears. Sound is produced due to the vibration of objects. Vibration is the rapid to and fro motion of an object. Let us explain this with the help of an activity. Take a table tennis ball suspended with a thread as shown here. Strike the prongs of a tuning fork on a rubber pad and touch it with the vibrating prong. What do you see? The ball is pushed away repeatedly. This shows that the prong is vibrating and this vibrating object produces sound.